So, what is a regression? A regression is simply an averaging line or an averaging line that splits a bunch of XY observations. Okay? That's what a regression is. Okay? You have a bunch of XY observations, so for this value of Y, you have this value of X. For this value of Y, you have this value of X. And a regression simply puts a line down the center of those observations to give us some average relationship between X and Y. In other words, some average slope. A regression is also going to give you some intercept as well. Okay, and in this case, in basic regression analysis, this can be mathematically represented as a linear function. Okay, and we know what that is. That's simply a different version of y equals mx plus b with an error term on there. Now, I'm not going to go into what this error term represents. You should already know that. It comes from the difference between the actual observation and the regression line itself. But I'm not going to get into that. What you really need to know is simply that a regression tries to estimate the average effect of X on Y. It's as simple as that. It's very simple. That estimation is represented mathematically as Y equals A0 hat plus A1 hat X. Okay, that's an A. A1 hat X. Okay, these are the estimates of the estimators. Okay, the estimator for the constant term in the original formulation is A0. The estimator for the slope coefficient is A1. The actual estimate of A1 is A1 hat, and the actual estimate of A0 is A0 hat. A1 hat and A0 hat are actual numbers. Okay, that is the actual slope of this line. That is the actual intercept of that line. So you can imagine A0 hat equals, I don't know, 4.67. A1 hat equals 0.92. Okay, we can rewrite that estimated function as y equals 4.67 plus 0.92x. Okay, and what this means is that if I have some value for x, say x equals 10, then the average value of y, the value of y given that value of x, is going to be y equals 4.67 plus 0.92 times 10. Okay, and whatever that comes out to. So that would be y equals 4.67 plus 10 times 0.92 is 9.20, and therefore y equals, this is where I need a calculator, equals what, 13.87? Okay. And so what this means is that if x equals 10, then y on average is going to equal 13.87. So focus on what a regression is, how to kind of interpret basic results from the regression, and that's going to be a focus of a question or two on your quiz. The next topic I want you to be refresh yourself with, because again, all of this none of this should be new to you, is inference. Okay, and we just actually performed some inference. Okay, now Inference is simply the interpretation, or at least in our case, the interpretation or the full and complete interpretation of results of our the regressions that we run. If we go back to that last this last just kind of ad hoc example I gave, we can see that I said, well, let's just assume that the slope was 0.92 and the constant was 4.67. The problem is we can say that all day long, but it may not actually be correct. Yeah, the numbers are what the numbers are, but are those numbers, given the variation in the data, are those numbers statistically significant numbers or not? In other words, is this a significant effect of X on Y? So even though we've covered one level of inference, and that one level of inference is the value of the coefficient. I cannot write today. Is the value of the coefficient. The final level of inference, or in many cases the most important level of inference, is the statistical significance of that coefficient. And to determine statistical significance of the coefficient, we're going to be using p-values in this course. Now again, you should already know this stuff. You should know what statistical significance is. You should know what p-values are and how to interpret them. That said, in this course we are going to focus on significance when p-values are less than or equal to 0.10. For p-values that are less than or equal to 0.10 but greater than 0.5, excuse me, that is my first screw up. Don't worry, I'll do it many more videos, trust me. Between when p is less than 0.10 but greater than 0.05, we're going to say that the effect of X on Y is significant. Okay, for the purposes of this course. Okay, that's a G, by the way. You have to pardon my printing. I can't, and you certainly don't want to see my handwriting. Printing's what you want to see, and that's not very good. Oh well, the age of computers, right? But when we get p-values between 0.05 and 0.1 inclusive, we're going to say that the effect of X on Y is significant for the purposes of this course. And when we get p-values that are less than or equal to 0.05, we're going to say that the effect is highly significant. So keep that in mind when we move forward in the course, especially for the purposes of writing the paper and the jargon we're going to be using in that paper. That said, what is, so we just went over the interpretation of the value of the coefficient, etc. In the book, chapter 1, again, you need to follow along in that. You need to, there's an example in there that carries through from almost page 1 to the end. You need to go ahead and follow that example, duplicate that example, every single step of it. It's going to go a long way in helping you refresh your memory of all these topics in basic regression analysis. That said, so we have the first level of inference, which is the calculation or the estimation of the coefficients, and the constant term, and how that number is estimated. Then we have the second level of inference, which is whether that's actually a significant effect or not, and a statistically significant effect. And we're going to use this p-value criteria here. Okay, so keep that in mind. What is the p-value telling us? Well, it's obviously telling us whether the effect is non-zero or not, but really, in essence, you can think about it like this. You can think about a coefficient value that you get. Given the variation in your data, given the variation in the possible values that coefficient could take on, is that value non-zero in a statistical sense? Okay, is it non-zero in a statistical sense? If you have a lot of variation in your data samples, and again, the book goes through all of this pretty well, you have a lot of variation in smaller samples pulled from your actual data set, then you could get coefficient values that are all over the place. And it could be the case that even though a coefficient value is say 0.92, that's actually not a significant value, that we cannot then say that the slope is 0.92 in a statistical sense. All we can say is that there's no effect between x and y if there's enough variation in our sampling process. And so what calculating the p-value does and interpreting the p-value does is it gives us a level of confidence that we can effectively say whether that estimated coefficient does represent a significant effect of x on y or not. Okay? That's a topic you need to know for the quiz. Something else you need to know for the quiz is marginal effect. Marginal effect, or effects. Again, you already know what a marginal effect is, okay? There's supposed to be an R in there, by the way. You already know what a marginal effect is. You should know what a marginal effect is. Marginal effect is simply the derivative of y with respect to x. Okay, and in our case, since we have a linear function, obviously that's going to be a1. Okay, so the estimated marginal effect, the estimated effect, if we change x by 1 unit, how much does y change? In our case, the estimated effect is going to be a1 hat. Now, even though way back in this first page that we went over, I calculated the total forecasted value of y by plugging in estimated values of both a1 and a0. In economics, the vast majority of the time, all we're really interested in is a1 hat. Okay, we economists perform marginal analysis. That's what we do. Remember back in introductory microeconomics, we were talking about marginal benefit and marginal cost and marginal product and marginal revenue. All that. So we interpret, or we use marginal analysis. And so when it comes to econometrics and regression analysis, most of the time what we're mostly interested in is simply that marginal effect. And for a linear function, it's simply the slope coefficient. So be able to describe and tell me what exactly that marginal effect represents. And again, the book goes into this pretty thoroughly, and you certainly should have learned what marginal effects are in your econometrics course. The chapter finishes up with a topic that branches the standard linear model that we're contemplating the relationship between x and y on, by including, it branches this out by including a possible z variable into that model. And of course there could be other variables as well. Now the point of the z variable, z is sometimes called an omitted variable. The point of the z value is to, the z variable and its inclusion into your regression equation, is to hold constant some characteristic that can affect x, the relationship between x and y. Okay, and that can be very important, because you may run a regression without z and get one value for a1, one marginal effect, okay, some value of marginal effect, regardless of its statistical significance. But once you include z, that effect changes considerably, and that's because you have some important variable out there, access to some data, that if it's not included in your regression model, can actually do what we call bias. It can bias the estimated value of a1, and so including it helps us sort of pin down what the actual relationship between x and y is, without the influence of whatever makes up z. And this is many times called an omitted variable. So the chapter kind of ends up in that area. Okay, so the bottom line is, what's important for the for you to know on the quiz and to refresh yourself with: what is a regression? Okay, be able to think about what a basic regression is. Now, chapter 1 is only about linear regressions. We get to nonlinear regressions in chapter 2. That'll be for quiz 2. That's not right now. Be able to think about how to, or what the estimated values of the coefficient and constant terms are. Be able to think about and calculate the forecasted values of y, okay, given some value of x and some value of a0 and a1. What exactly is a marginal effect, and what is it telling us with regard to the interaction between x and y? How to draw inference from that marginal effect. So if the marginal effect is simply some coefficient value, okay, how do we interpret the significance of that effect? How do we draw both levels of inference from that effect, and what does it actually mean using some sort of criteria we set forth? So for instance, you can imagine a question on the quiz. One of the questions possibly, and I say possibly because maybe not, I might not ask a question like this, but just imagine a question where I take one of the tables from the book, one of the output tables from chapter 1, which you see in the book, and you know, say but I use different numbers, different coefficient values, different coefficient estimates in the table, but I give you a table like that, and I say, okay, draw both levels of inference from these results, and then calculate the forecasted value of y if x equals some number. Okay, well, I'm going to expect you to give me that information. I'm going to expect you to interpret using both levels of inference, using not only the value of the marginal effect, but also the statistical significance of the coefficient, giving our prescribed criteria that we've laid down, and then I'm going to expect you to give me the full interpretation of the results, which would be including the constant term and simply cranking out what the estimated value of y is, what the forecasted value of y is given some value of x. Finally, I want you to focus on what adding a z variable does or can possibly do to the relationship between x and y. Why would we want to add a z variable? When would be the cases that we would want to do this? What could be the possible changes in outcomes between x and y if we add a z? Okay, so be thinking about that. And again, all this is covered in chapter 1. I'm just covering, just kind of using this as a study guide, so to speak. This video is more of a study guide. Again, all this stuff you should already know from your econometrics courses and other courses as well. So none of this should be new to you. Again, the quiz is going to be 4 or 5 questions, and it's going to be focusing on these topics. The questions are going to be focused on these topics that I just covered in this video.